All right, so as to make it, you know, quite distinguishable. What I'll do, because I'm looking at 3 significant figures, I'm going to make sure that all of these have at least 3 significant figures. So some of them can't because, you know, well, I'm just going to do that. So 14.7, and then I have to give this one, you know, because the zeros in front, they're not significant. So the 0.0, these are not significant. That's significant. Standard deviation needs 3 decimal places because that makes it's 3 significant figures. That's what I'm saying. That variance, same thing. Kurtosis only needs 1. Skewness needs, I'm going to choose 3. And we need 3 significant figures. Now, see that 0 in the range? That 0 is significant. The minimum, the maximum, those are fine. The sum, I guess we could do it down to 3, but at this point, you know, the sum is different. You're doing precision measurements. So precision measurements involve the decimal place. And so we have 1 decimal place, and you see we have 1 decimal place. And it's 101, that's the count. And the confidence level, I'm gonna go ahead and give that 3. The count is, we don't need any decimal places there. Okay, so now if we look at the mean of the statistic and we look at the mean of the normal distribution, so it's almost like the descriptive parameterization of the normal distribution, even though we call it, this is the population. So look at our mean here, it's 14.7. We chose 100 points, we still get 14.7. The standard error, I didn't do that over here. So the median is 14.6. Over here is 14.7. You'll see that not much is changing. Deviation is 0.667. Over here is 0.691. Range 30.1, and this range should be, let me see, where's this range? 4.3. Okay, and let's look here. We have our variance. It's 4.78 over here. And over here we have our sample variance. It's 0.444. Y'all see what's happening? So as you take more and more samples, you will move closer and closer to the actual normal distribution here. So I'm going to go ahead and produce another graph. I'm going to insert. I am going to call this the this guy, I'm going to still call it normal distribution of the ball mass statistic. Again, that is a probability, so I'm going to go ahead and say equals to, just like I did before, norm dot dist and open parenthesis, select N2, and we want the mean over here. So I'm going to select this mean, and I'm going to use my function key in F4. So if you're on the Mac, you use that function key in the lower left-hand corner, and then F4, your function key up at the top. Comma, I'm going to select the standard deviation. I'm going to hold my function key down again, and then F4, and it's just making them static for me, comma, false. I'm going to go ahead and double click on my fill handle. So on the iPad, of course, the fill pops up, but in this case, the fill handle is in the lower right-hand corner. I'll double click. Okay. So now I'm going to select N and O. So I hold down on N and then drag to O, because now I want to produce a graph. Another scatter plot. So here is our scatter plot, normal distribution of the statistics. So I want to put it right under here. One day I'm gonna figure out how to put both of these on the same graph. I'm sure they have a video on YouTube. So I'm gonna place this right here, make it probably the same size. And I'm gonna try to be as descriptive as possible. So this is gonna be ball mass, again, grams. And then we need our vertical. This is going to be the normal, comma, paste, normal distribution. And I'm going to go ahead to home and make this much smaller. All right. So that's the normal distribution of the ball mass statistic. And up here, we are going to have the probability of the ball mass statistics. So I'll go ahead and hit that. Now we see we still have our squiggly lines. Of course, we don't want that. So I am going to, first of all, hit save. And then I want to sort. So I'm going to go ahead and go to sort first. I was just wondering, could I throw this down? No, I can't throw it down. That's the iPad feature there. But I'm sure that there's a quick way to go all the way down. So I'm going to go ahead. Oh, I'm on the laptop now. So the sort is going to skip the first columns. So if we look over here, this is the probability. Let me go down because that's the first one. If I go here, it didn't sort it. That's because I'm on the wrong one. Oh, I'm going to select here, and then I'm going to sort again. So now if I go to the graph down here, it should be from right to left. So again, let's take out our 17.4. If there must be some 17.4s. Ah, there's one. So I'll just cut that and just take it to the top up here and say outlier. Then paste. All right. So we go over here to this graph and let's look at it. So it hadn't removed it. So I'm going to right click and clear contents. And if we go back into our graph here, you'll see that we have this nice smooth graph. If I click on the number line, horizontal axis, I'm going to have the ability to change my range minimum bound and my maximum bound. And here we go. Okay, and if we looked at both of these, it's almost the same. I have got to learn how to put these on the same chart. But they're almost the same. You see that? So that's part of the power in statistics. The power in statistics is that you don't have to count every product that you're making. In particular, if you're making 1 million in one day, my goodness, you want to count 1 million? No, you don't. Go pick a sample of 30 every hour to check to make sure you're continuously producing a quality product. Same for anything. All right? All right, that is it.